In this animation, we see that we have a sealed container with some gas particles inside, and we have a fixed mass of gas or fixed number of moles of gas. And we've got a pressure gauge at the side here. We notice that the gas particles are moving rapidly and randomly, and when they collide, perfect elastic collisions, they exert a force on the inside of the container, creating a certain type of pressure. We can see with this setup, as we push down on the plunger, we are decreasing the volume and we are measuring the pressure that is being exerted by those gas particles inside. So we've got some values that are being plotted here. And here are enough values, quantitative data that we can take a look at. So when the volume is at 50, let's say centimeters cubed or 50 milliliters, we notice the pressure is 1.2. And if we look at 21.4 milliliters, the pressure is 2.8. Now we notice something interesting is happening. When we multiply those two variables together, we end up getting a constant of 60. So here we can kind of take a look at the relationship between volume and pressure. When volume goes down, pressure is going up. What we'll do next is we're going to plot these values and we're going to see what relationship is observed. So we can notice from this pressure versus volume, when volume is low, pressure is high. So we take a look at where it would hit on that curve. We notice that the slope is changing over time. And so when volume is high, we've got low pressure. So we can see that when the pressure is doubled, the volume is halved. If the pressure increases by 3, then the volume decreases by a third. So the volume and pressure are inversely proportional. If we take pressure and we plot it with the reciprocal of volume, so what that means is if I took each of my volumes and I did 1 divided by 50 on my calculator and I plotted that point, 1 divided by 37.5, and I plotted it against the same pressure values, I would notice that I get a linear relationship. So pressure versus the reciprocal of 1 over volume yields a direct relationship, meaning that when pressure goes up, the reciprocal of volume also goes up. So we can derive Boyle's law from this relationship. P1, V1, known as initial pressure, initial volume, at the start will equal the final pressure and the final volume, P2, V2, at the end of the experiment. So here, what we should get from this is that as the volume decreases, you have an increase in number of gas particles per unit volume. You get more collisions because, again, those particles are confined to a smaller space, and you therefore get an increased force due to those collisions, which increases the pressure.